Hello friends, I welcome you in lecture number 10 on exponential distribution. In this lecture we will discuss one more problem on exponential distribution. So first we understand what is this problem. If the cumulative distribution function of a random variable denoted by capital X is given by fx equal to 1 minus e to the power minus x for x positive, then find the expected value and the variance of random variable x. Here we are given the CDF or cumulative distribution function of a random variable denoted by capital X, and using this CDF we have to find out the expected value of x, or we can denote it by this mu, and the variance of x, which we denote by sigma square, or this notation also variance of x. We know that if we want to find out expected value and variance of a random variable x, then we have these formulas. Expected value of x is given by x times fx dx, integral of this x times fx with respect to x, and from minus infinity to infinity. And for variance of x we have this shortcut formula also. We have to find out expected value of x square and minus square of mean of this random variable x. So we can use these two formulas if we are familiar with the probability density function, which is shortly known as PDF, of a random variable x. If PDF is given, then we can find out mean and variance of given random variable. But here PDF is not given, we are given the cumulative distribution function. So what we can do is, we know that if we want to find out PDF of a continuous random variable from its CDF, then we have to differentiate CDF with respect to x, and we will obtain our density function denoted by fx. So this is one way to find out this mean and variance of a random variable x whose CDF is given. But if you recall that we are having some standard random variables whose CDF and PDF are standard, and we can decide from the formula itself what are the expected value and variance of that random variable. So if you recall in earlier lectures of exponential distribution, we have seen that CDF of exponential distribution is given by this formula 1 minus e raised to minus lambda x, where x is greater than 0. And we know that PDF of this exponential random variable is given by lambda times e raised to minus lambda x. So whatever lambda we are using here, that lambda is used in CDF also. We have also discussed that if lambda is the parameter of exponential distribution, then mean of exponential distribution or exponential random variable is given by 1 divided by lambda, this parameter, and variance is given by 1 divided by lambda square. So you can see given CDF is in this form 1 minus e raised to minus lambda x. So we can compare this CDF with the CDF of exponential distribution, which is 1 minus e raised to minus lambda x. So if we compare these two functions, we can see that here coefficient of x is 1, here it is lambda. So we can say that lambda is 1. So this is the CDF of exponential random variable in which parameter lambda is 1, and once we identify lambda, we can find out expected value and variance using these two formulas. So this is one way to decide the mean and variance of exponential random variable. So we can first write that here we are given that CDF is 1 minus e raised to minus x, and we can compare this comparing with, we know that CDF of exponential random variable is given by 1 minus e raised to minus lambda x. So if we compare this given CDF with this CDF of exponential random variable, we have lambda equal to 1, and here x is exponential random variable, so we have ready-made formulas for the mean and variance of x. So mean of x is, or expected value of x is denoted by e of x, and it is given by 1 divided by value of parameter lambda. Here lambda is 1, so we have expected value equal to 1. Similarly, we can write variance of x, which we denote by this notation also, and it is 1 divided by square of lambda, and here lambda is 1, so we find that variance of x is also 1. So this is very easy question. If you are familiar with the CDF of exponential distribution, then you can compare given CDF with CDF of exponential random variable, and you can decide the parameter lambda, and using the standard formulas of expected value and variance of exponential random variable, you can directly find out this mean and variance for the exponential random variable whose CDF is given. So you must remember this CDF of exponential random variable. If you remember this, then only you will be able to determine that whether given CDF is that of exponential random variable or not. And once it is the CDF of exponential random variable, you compare with this standard form, identify the value of lambda, and we know that if lambda is the parameter of exponential distribution, then expected value is given by 1 by lambda, and variance is given by 1 by lambda square. Now suppose you don't want to remember all these formulas, then you can go in general. We know that if we are given the CDF of continuous random variable, then we can determine the PDF by taking derivative of CDF. So in this way we will obtain PDF of given random variable, and then we have the formulas for expected value of continuous random variable, which is integral of x times fx with respect to x, and for variance we have to use sigma square equal to expected value of x square minus square of this expected value of x, or square of mean. And to find out expected value of x square, here we have to replace this x by x square. So we can go either in this way, or we can use the standard form of exponential distribution, and we can identify the parameter lambda, and using that parameter lambda we will be able to determine mean and variance of given exponential random variable. So this is all about this session. I hope you like it. Thanks for watching.